Good afternoon, everybody. I'm making this presentation on behalf of Dr. S. Gangopadhyay, Director CRRI, who is unable to present in this meeting. So I'm Dr. E Madhu, Principal Scientist from Central Road Research Institute. CRRI is a part of CSIR, one of the 37 laboratories it has, does research in roads and transportation. I belong to Transportation Planning Division, and my colleagues are also there, Dr. Punyama Parida and Dr. K. Ravinder. So, from the morning, we are already seen that many presentations focusing on urban trends and all those things need for the understanding about the problems, urban problems. But I may not be focusing on that because everybody has idea. So, I'm just coming to the main point. At CRRI, what initiatives we have been taking in terms of conducting some urban studies like traffic studies, environmental studies involving air pollution, noise, and also recently what experiment CRRI has done in terms of data collection or evaluation of systems. So I will present very briefly, and at CRRI what future work we are going to think of in terms of research that I will highlight. So if you see recently at CRRI, we have done a study like road traffic and air pollution of Delhi and other 8 metropolitan cities like Delhi, Mumbai, Kolkata, Chennai, Bangalore, Hyderabad, also Agra and Kanpur. So all these urban areas we have conducted a traffic study and estimated the traffic loads in that urban areas, and afterwards estimated the pollution loads coming out of from the vehicles, and then we evaluated some kind of policies. Finally, it went to develop national auto fuel policies. Like this is some results I am presenting. Like these are the comparison how the traffic loads are there in these 8 cities, 8 major metropolitan cities, and how these pollution loads are distributed over the cities, and also estimated how much traffic is entering daily to the city and leaving the city, how much is the passing through the traffic. These kind of things have been estimated in the city so that it will be useful how the bypasses are required for these cities and how much more economical if you construct these bypasses. And these results are going to be very useful input to those studies. Like this graph is telling how VKT is increasing over the years. VKT means vehicle kilometers traveled. These results are particular to the Delhi city. VKT has increased double over the years. This graph is telling in 2 years, that is in 2002 and 2009, how it has increased. Total VKT is increased more than 100% actually in less than 7 years. And the subsequent graph, the lower graph, is actually telling how the pollution levels have come down over the years from 2002 to 2009 because of the so many policies like implementation of Bharat stage 1, 2, 3, and also introduction of CNG in autos, buses, all those things. So because of that, pollution loads have really come down compared to 2002. But somehow these pollution, actually we are not able to get the benefits because of the congestion occurring at the intersections and flyovers. So all these benefits are actually nullified due to the congestion. So this study also recommended what is the network to be upgraded in the urban areas. This is particular to the Delhi. We need to upgrade these networks so that we can obtain the free flow conditions in these major road network. This is about the Delhi and Mumbai, Kolkata, and also Hyderabad, Chennai, and Bangalore. And another interesting study we are doing at CRRI, that is noise mapping, how the noise is affecting the residential areas. This particular picture is telling the change of noise levels from in different years. This is showing 2009 at the left side, and this is a recent analysis 2013, how noise levels are increased in this particular residential area. So this is about the residential area, and this result is showing at the Ashram Chowk, New Delhi, how the noise level is there at the moment. This is the present noise levels at Ashram Chowk, how many families are affected and all has been analyzed in this study. Like other experiment, I want to tell what CRRI is doing. This is studying the evaluation of automatic traffic counter cum classifier. As we have seen in the morning, there many institutes are actually going for ITS application, intelligent transportation systems and all. All these systems actually work based on the data collection. If your data collection is not able to get the data accurately, then whatever the information you are going to give to the user, that may not be actually reliable. So road user may not be able to believe the information what you are supplying. So we have to focus on data collection technique, and some accuracy should be involved. One type of one type of technique we have evaluated at CRRI, that is automatically traffic is counted by this infrared based technology. Like vehicle passes through between these transmitter and receiver, vehicles are getting counted and classified. But to evaluate this system, this is Australian technology. We selected some studies in selected some sites in Delhi and collected the data and compared with the observed data. But unfortunately, this data is showing some errors when you compare with the observed data. When the traffic volume is very less, these automatic counters are giving really very good accuracy, more than 90%. Whereas when the traffic volume is increasing, then your AVCC, that is automatic vehicle counter cum classifier, is giving lesser count than observed data. That means when the headway is actually reducing less than 3 seconds, then your accuracy level is falling very rapidly, and your error is going to increase exponentially. Whereas more than 3 seconds headway, the error accuracy will be very you can say more than 90%. Other experiment is at toll plaza, that is yes. So we did that toll plaza and did the simulation and estimated various options. You all know that at Delhi Gurgaon Expressway we have a lot of queues at the toll plaza. We use the simulation technique and given the options so that we can optimize these delays and reduce all those delays, and evaluated a BRT corridor and did some experiments by allowing other vehicles also in the BRT corridor. And we have taken, these are parameters, total travel time, value of time, queue length, and user opinion. Then future work, what we are thinking, going for urban transportation strategies for Indian conditions, because normal techniques we don't combine environmental and traffic thing together, but what we are proposing is considering both at the same time and go for some kind of visualization. Right now we have only showing 2-dimensional visualization, but it is very much required to go for 3-dimensional and all. So for that we have to think about some kind of softwares and urban strategy which is available at TNO Netherlands and all. So we managed to prepare a proposal and we are awaiting for the approval. So this is the objective of that proposal, which is going to be carried out in the future. And also our plan is to develop a sustainability for transportation. As we all know that these days transportation is responsible for global warming and all. To considering all these things, we proposed a project, sustainable transportation, to develop sustainable integrated mass transportation and also sustainable non-motorized transportation using some ITS technologies. For this we will be expecting that to prepare a framework and guidelines to design sustainable integrated mass transportation system and other ITS technologies. And also going for a highway capacity manual for Indian conditions, especially for urban areas, considering other aspects like intersections. And we are thinking in this direction of considering soft computing techniques in travel demand modeling and also dynamic traffic assignment. With this, I will conclude my presentation. Thank you.